All right. Thank you everyone for coming to the University of Texas Energy Symposium sponsored by the Energy Institute. I'm Kerry King. Before I introduce today's speaker, I will note that the Longhorn Energy Club is having a happy hour right immediately following today's event, I guess starting around 6:30 at Schultz Beer Garden, which is on San Jacinto, right? So hit your local watering hole and continue the conversation, and then perhaps we can convince the speaker to go with me as well. I don't know. Next week's talk will be a local person, postdoctoral fellow, Tim Siegler. He works in a group associated with the Center for Next Generation Photovoltaics. So one of those next generation technologies is perovskite materials. So I can say the word. I can't tell you much about what that means. So if you want to know what the role of new materials of perovskites in future solar panels, then next week is your talk. Today we have Saleem Ali from the University of Delaware. He also has an appointment with the University of Queensland, where he used to be a professor there, and he's now moved to Delaware over the last 3 years ago. He's done a variety of things, and he holds a variety of roles. He has a role within the UN in their Global Environment Facility, helping distribute money and understand some of the environmental studies they do. He's on the role with the international the resource group there. It's kind of like the IPCC for resources, so he helps govern their reports and strategies of understanding materials. He's written several books, over 100 publications, so he's got a lot of knowledge in the area of understanding environmental, social, and energy conflicts and boundary conflicts between countries, and how to use these kinds of environmental issues to achieve peace outcomes between countries. So he's very much at the realm of the interface of energy, the environment, and social impacts. So that's why I'm quite pleased to ask him to come here. I met him a couple years ago at a conference on resources in Canada, and so 2 years later I've got him here to be a speaker. So his talk's going to be on critical metals or critical materials for energy applications. And with that, I will let him take it away. So let's welcome our speaker, Saleem Ali. Thank you very much.
Okay. Thank you. Thank you very much, Kerry. Can everyone hear me? All right. Great. No, it's a pleasure to be back at UT Austin. I've been a couple of times in different roles, but I think last time was almost a decade ago, so a lot has changed in Austin, generally for the better, it seems. So the topic that I'm going to cover is very current in many ways, and current in every sense of the word. It's really an issue that is now being raised at the international policy level. It's being raised in the business world, and it's clearly on the minds of engineers and technical professionals, such as many of you, or aspiring ones at least, the students who I'm sure have promising careers ahead. So it's an area which I operate in, which is between this interface between natural science, engineering, and social science and policy. And so I love that mud pit where you are dealing with a lot of the technical issues and you're trying to then apply them in a policy context. And my own background, I especially enjoy working now on this issue of the elements for energy, because my first degree was in chemistry. And then I moved more and more towards environmental science, and then more towards environmental planning and geography. And so for me, this is a way to reconnect with my chemistry roots as well. So how is it current? Well, this is the news that is really making a lot of splash currently at the State Department, of all places, that this new initiative has just been launched over the last 2 months at the US Department of State. And it's called the Energy Resource Governance Initiative. It's been spearheaded by the current Secretary of State, Mike Pompeo, but also it's an opportunity to connect the Department of State and its efforts with the Department of Energy and other parts of the US government. And what has motivated this, you could only guess. And since majority of the audience is students, from what I've told, I might use a bit of the traditional pedagogic style in my presentation. So why I'll ask you this, then why do you think the Department of State would be interested in this? These are people who run embassies and issues visas and stuff. So why are they interested in having an energy resource governance initiative? There are international issues, and yes, so energy itself, the supply of energy is an international issue, absolutely. But there's another important connection to that, is that there are security issues increasingly. And there has been, of course, a great degree of anxiety about the dominance of certain countries in terms of their supply of certain strategic minerals, namely China. And so a lot of this has come about currently because of the anxiety that has been accumulating over the past 6-7 years, that about 90% of the supply of certain critical metals comes from China. And because of the current trade conflict, one may call it that. I wouldn't call it a war. I think that's a hyperbolic statement, but one can call it a conflict, perhaps. There has been growing anxiety about the impact of that on U.S. Energy security. And so this initiative has just been launched to try and address this at multiple levels. So going back to my chemistry roots, the world has become much more complicated. Just as we have far more ingredients in our granola bars and cereal packets, we've got also far more ingredients in terms of elements in our daily lives and our electronics and our the whole panoply of infrastructure that we use for our modern lives. So in the 1990s, essentially we had, in terms of the kinds of metals and materials that were being used in certain electronics, there were relatively few that were considered particularly critical in many ways. But now you've got, and this is information coming from a variety of sources, you've got such a wide variety of elements that are now being considered a cause of great concern in terms of supply security. And the ones that you often hear about are the rare earth elements, and sadly a lot of the popular discourse has lumped together a lot of metals as rare earths. So just for a refresher for the students, especially in terms of chemistry, when we talk about rare earths, we're essentially talking about the lanthanides that are here. Those are the rare earth elements. But we get all these other elements often get lumped together with them, like you've got niobium and some of the other transition metals. But this is the rare earths are the ones where the anxiety over China came about, as in 2010-11 the price of rare earths became very high, and some of these rare earths are particularly important for the renewable energy infrastructure that we use in terms of wind turbines, particularly magnets that are used there. So elements like neodymium particularly. So that has been the cause of this anxiety that has been growing. And so the Energy Resource Governance Initiative is going to try and address that moving forward. Now, on the other side of the Atlantic, there has also been concern around this criticality question. The people have been asking, like, what metals are actually critical. So I've given you one reason for calling them critical is because of their need for energy infrastructure. But there is also criticality in terms of economic dependence on certain sectors. So for countries like Germany, for example, there is clearly going to be a concern around metals being used for the automotive industry. And so that's going to make a difference for the German economy if they're not going to be able to supply enough cobalt for batteries and electric cars that Germany has banked on in terms of the future growth of some of their automotive industry. So this is how they've defined, they start off with, they've got this kind of upside down pyramid that the European Commission prepared in 2015. Initially they had 60 materials, then they went down, 33 materials used in low carbon technologies. So they're also concerned in terms of their Paris Agreement targets and how they're going to meet those. So a lot of the motivation after the Paris Agreement was signed came around not only for their own energy infrastructure, but also for devices and for vehicles and transport, which would address those. So that's why you have, for example, graphite in there, because that's going to be very significant for e-mobility. But you also, have to keep in mind there's some of these elements which are going to be used for solar panels, and we're also, of course, interested in LED lighting, for example, where you have gallium that's going to be used. So if you need low energy lighting, there's going to be greater need for those kinds of metals. In fact, the Nobel Prize a few years ago was given for that discovery of the gallium compounds that are used in LED lighting, in the Nobel Prize in Physics. So, you have a lot of this kind of work that has been going on that the Europeans have been paying a lot of attention to. So they have then come down to essentially these 8 materials on their end that they consider very significant. You can see there that there's some rare earths. You've got dysprosium and europium, terbium, yttrium, neodymium, praseodymium, gallium, and tellurium. Tellurium is particularly interesting in terms of its use in solar panels, and it's an interesting one also because it's cadmium telluride, and it creates a disposal problem because, as you've probably heard, cadmium is toxic, and so here's you've got a great green technology, which is the solar panels are very efficient relatively, but then you've got a disposal problem, which leads us to questions about circular economy and recycling and so on. And we just had a conversation that you've got great research going on here at UT Austin about finding more novel ways of extracting materials from waste. So this is what the European Union is saying in terms of their criticality question, and a lot of it is energy related. Now, in 2017, President Trump issued an executive order in December, and a list was issued a few months later. And criticality, according to the US Geological Survey, was defined as such. And I would urge you to consider this definition, and some of the subsequent slides will unfortunately defy the usual guidance you get on PowerPoint slides not having more than 4 bullet points. So pardon me for that, but I'm doing that particularly so that for the record you have that material. So I'll breeze through some of those. But here, a critical mineral is one, according to the Secretary of Interior, who has been tasked with this, basically it's a non-fuel mineral, but it's essential to the economic and national security of the United States. So, so they're saying non-fuel, but that non-fuel doesn't mean non-energy. It's basically that it's not the primary source of energy. So we're not talking about coal, for example, but it's being potentially used for national security issues. Certainly energy is part of the national security apparatus, the supply chain of which is vulnerable to disruption. So that disruption could be due to scarcity, absolute scarcity, but it could also be due to the fact that you don't have security of import, as is the case with the concerns with China, or it may be it may not be just China because of the trade issue. It could be cobalt in the case of the Democratic Republic of the Congo, which currently supplies 65% of the world's cobalt. And here the issue is not that the country is in a trade conflict, it's because the country is politically unstable and is potentially volatile enough that there could be a disruption to supply security as a result of that. And having visited the DRC, I can say that there is enough cause for anxiety there in terms of what could happen potentially if there was a supply disruption. And then thirdly, it serves essential function in the manufacturing of a product, the absence of which would have this implication. So that's how it's been defined by the USGS. Now, these were the key provisions of the executive order, and that's why I put them up there, because I think it's important for you to have this for the record if you're later going through the PowerPoint, because I can't do justice to everything in the short time I'm allotted. But clearly there are these elements in here, which is that there has to be a plan to improve look at those terms, I'd highlight those particularly, a plan to improve sorry, this is not working, but anyhow, the topographic, geologic, and geophysical mapping of the US and make the resulting data and metadata electronically accessible. This is important to keep in mind. Oftentimes people think that, USGS publishes all this data and we're in good shape, but the resolution of that data is not often very useful for economic geology purposes. It's fine to be used at a very coarse level, but it's often not as useful for when you're going to be having extraction for economic purposes. Then there was also this recommendation, which you would expect from, the current persuasion of the government, which is to streamline permitting and review processes and develop, less barriers to those kinds of mechanisms. And so what was set forth by the executive order was that there had to be a strategy developed. Okay? Now, in June of this year, this strategy was released. And it took a bit longer. They were given 180 days to do this, but it took considerably longer to do it. The strategy, which you can download in a very obscure part of the US Department of Commerce's website, it's not very easy to find if you Google it, but if you really want to see it, let me know and I'll find it for you and send you an attachment. But the strategy is, and they just uploaded it as a Word file, which is really odd also. So it was like really done in a hurry to let's just get it out there. And it's basically, laying these 6 points of what needs to be done in terms of these critical materials that need to be considered. Some of it is like been there, done that, and it makes sense. Strengthen America's own industrial base around these issues, that there would be an ability to also consider alternatives, better separation purification technologies. These are the kinds of things which would be very well supportive of the work that is being done here in the UT Austin research programs, because there is going to be more funding clearly based on this for that kind of work. The US Department of Energy has had a Critical Materials Institute, which has been funded for about 5 years or so, that's based at the Ames Research Center in Iowa. There's the Ames one in California too, but this is the one in Iowa. And they have been partnering with Colorado School of Mines and a few other universities to do some really interesting research around a wide range of substitutes and other ways of addressing some of these issues. But this strategy tries to kick it up a notch in terms of what can be done further. And one of the things that is important is also in terms of this number 3 point, which is enhance international trade and cooperation related to critical minerals. And this is one where it's a kind of it seems counterintuitive to what is actually happening on the policy realm. And that's where my concern comes in terms of what will move forward, because you have part of the establishment saying, we want to have a more protectionist approach, and you have the other side which is saying, you want to do more trade and cooperation related to critical minerals. You can't choose your partners when it comes to geologically determined reserves. If the reserves are in China, they are in China. You can't, geology does not obey the axioms of politics. So you have to then think through what will be done. That means that you have to find mechanisms for cooperation. You can't assume that cooperation is going to happen. And that's some of the work that I've tried to do in my work. So going back to what the European Union has been doing, and I find their approach to be fairly pragmatic. A lot of their focus in terms of energy, and this is coming from particularly on the Joint Commission's work on energy, they've divided it up into essentially these areas, and you've got the carbon and graphite for the e-vehicle usage. You've got those 3 major rare earths, which are then going to also be used for wind particularly, and clearly, Texas is a leader in this regard with the amount of wind capacity that is available in the state. So you've got a lot of those elements hanging around West Texas and these wind turbines. And then you've got the tellurium, which I mentioned for the photovoltaic cells, and that's also then linked to the lighting. So they're trying to put that forward. Interestingly, the one reason I put this graph up, with this chart up, is the nuclear part is also mentioned, and they have put in hafnium in terms of if this was being developed. Now, generally, these are sort of the next generation of nuclear reactors that might well be safer and may be able to reprocess some of the waste that is coming out of either decommissioning of weapons or other sources. This is a tricky one because generally, there is a move away from nuclear. There are a few countries which have invested. In Europe, Finland continues to consider nuclear as a prospect, and they have built a nuclear power plant. And then you have in East Asia, and you have in the United Arab Emirates and a few other places where nuclear power continues to grow. In the US, we have just had one recent new nuclear power plant which took 20 odd years to build, but it's just recently opened in Tennessee. But otherwise, it's not that likely to move forward, but let's keep it up there. Now, the research on trade flows just of one metal, this is work done by a colleague who serves on the International Resource Panel that Carrie was mentioning that I also serve on. And this is some work done in Japan by Nansai and colleagues, and it's basically showing you how complicated just the trade flow of the metal is. So it's being mined, neodymium, a lot of it comes from those mines in Inner Mongolia, as well as some of the mines which you have in southern China and the rare earth clays. And then, it's being shipped down over to Malaysia, Singapore, the processing, enhancement, and then, it's going to all these different places in terms of the ultimate use of the metal. So, this is just one element. So you can think about what's happening with all these other elements, and we don't have any international governance mechanism which is able to track and trace what is happening with these flows. And so that's going to be, I think, an area of great importance for us to consider in the next few years. Just to remind you, if we were to think about projected demand for these metals, this is one of the classic papers that came out of the MIT Material Science Group in 2012. We can say, people would say, what has happened between, so this period we can now see whether their predictions have come to pass or not, and generally they have come to pass. So this is what they had projected in terms of demand for just dysprosium demand in terms of wind power and how wind power's uptake and upscaling is going to make a difference. So now what people have said is, well, ultimately there are always with anything like this, there are going to be critics, and you have scenarios, projections of demand going forward with any material. They'll say, oh, well, they will find, motors which don't need those magnets. And yes, they will be less efficient, but so what? And my response to that is, but why should we settle for having more inefficient outcomes, which can potentially be more problematic in the aggregate if you're thinking from an industrial ecology perspective? We should be thinking about what is going to be most optimal in terms of planetary impacts, both in terms of supply and the pollution and so on generated from the extraction. So this is something which we have to keep an eye on. This was their projection, is very widely cited paper, and it continues to deserve some further following. So those are the scenarios for greenhouse gas emission reductions. So 450 parts per million. You've heard about the activist group 350.org, their goal is 350 parts per million. So even this is not even looking at that. This is looking at 450 parts per million. And we've got, moderate electrification and historical growth. So this is serious business. Now, this is just to give you the Chinese context of this. China has been rapidly investing in overseas mineral exploration. So it's not just China domestically producing the minerals, but the Chinese government's long-range planning to make sure that they are also making sure that they're able to have supply for their industries from all over the world. That is the major thrust of the Belt and Road Initiative, which you've probably heard about already. A major thrust of it is to create corridors whereby minerals and materials can be better sourced for China, and that's understandable because they want to make sure that they have that supply security. So if you think about the investment in mining companies all over the world, like when I lived in Australia, one of the major Australian mining companies, which was Mount Isa Mines, Mount Isa is this iconic mining town in Queensland. It was bought by the Chinese state-owned Minmetals Corporation. They created a company called MMG, which is headquartered in Melbourne. So it's an Australian company. It's a member of the International Council on Metals and Mining, but it is wholly owned by the Chinese Minmetals Corporation. The management is Australian. So it's not just like, oh, the Chinese are coming, like Huawei or other companies coming in and opening shop here. It's done in a very, in, I would say, a professional way in making sure that, there's also lesson drawing from some of these acquisitions. So this is happening all over the world. And this is also really interesting is that if you look at overall Chinese overseas investment, the extractive sector, mining, dominates considerably. Leasing and business services is the highest, but after that it's mining. And the leasing and business services is a different story. Why like a quarter of Sydney apartments are owned by Chinese business people and so on. It's a different story in terms of a lot of the capital flight from ill-gotten gains and so on, which have moved overseas and other things. But mining is clearly very significant. So, but I don't see this as, we shouldn't, I don't want to label this as a threat necessarily. It's just, noting that this is the way things are. If we looked back, 50 years, we may have seen the same with particular, American enterprises moving all over the world as well, and investment and expansion and so on in various ways, and whether it's McDonald's or Walmart or other companies which, created brand America. So, countries look for their self-interest, and we can't blame them for that. Now, the other aspect which gets missed often in this whole criticality question is the role of recycling. And it's being referred to sometimes as urban mining. My colleagues in China, they often refer to it as anthropogenic minerals, which is, I don't know, the translation somehow seems to work out better for them, but we've been working on a paper currently which is under review in Nature Communication with some colleagues at Tsinghua University, and the reviewers were quite perplexed by this term, but the authors are insisting that that's what we call it. So, but we can call it urban mining, anthropogenic minerals, and so on, whatever you would like to say. But essentially, they are a significant source if we can find the right mechanism. So if you look at 10 kilograms of cell phones, this is research done by CSIRO in Australia, it's enough to produce a typical gold engagement ring. You have enough gold in 10 kgs of cell phones. And these are those old cell phones which are lying in your drawers probably. 1/3 of all cell phones ever manufactured are lying in drawers. And which is also, it's urban mining resource, right? Eventually, probably you have a few lying in there as well. So that is what we can do. Imagine how much ore you need to process to get the same gold. You need about 500 kilograms to 10,000 kg, depending on the ore grade, to produce the same amount of gold. So this is significant potential. Can we do this for the critical metals needed for energy? Important to consider. When can we do it? What should we do moving forward? There are some real wild cards out there. In North Korea, this is one of the things that people often talk about, that if we do run out of rare earth reserves, terrestrial rare earth reserves in some areas, one of the major areas that people have said that there is potential is in North Korea. And there is this company, actually an Australian company, that was trying to operate there some years ago. And there's a little known institute in Berkeley, California called the Nautilus Institute, the founder of which is this Australian-American guy, Peter Hay, who won a MacArthur Genius Grant decades ago, but he continues to do research on this stuff, trying to figure out what is happening with regard to the strategic depth around extractives in North Korea as well. So there's a lot of interesting material going on there that this could be a potential bargaining chip. If we think about energy diplomacy, other mechanisms, if there was a deal made, and that's why the State Department's involvement in this is particularly relevant. We could have this as a potential bargaining chip in the North Korean conflagration. So one of the things we have argued for, giving this context, was this paper in Nature we published in 2017. And when Carrie and I met in Vancouver, this is around the time this came out. We were, this created quite a lot of interest in some of the work we were doing. We got together with a group of researchers through the International Union for Geological Sciences, the IUGS, and we convened a workshop to think through what should be the way forward about thinking about international mineral governance. It was hosted by the Namibian Geological Survey, and we held it in Africa, particularly to give that importance to the continent, which has been, unfortunately, the subject of so much exploitation without as much in return. And Namibia is one of the few success stories where things have been better governed. And we came up with a series of suggestions, which I won't go through, but you're welcome to have a look at the paper. It's easily found there. And we have one of the charts we showed in that. We'd analyzed the data on exploration investment, for example. And this is what scares me. And much as I love gold as a South Asian, we have gold as our kind of main asset at marriage and so on. But it's a pity that so much of investment in exploration has gone into gold mining. So in the 1980s and early 90s, can you imagine about 2/3 of all global investment in exploration was going into gold mining? Now gold, more than 85% of gold is used in jewelry. So it's not a critical, people say, yes, it's used in cell phones and all, but the amount of gold you need for cell phones you can get from your artisanal miners probably in Alaska. It's not a big deal. We're talking about, most of it is jewelry, So why is it that just from a strategic point of view, this is a classic example of a market failure. Much as I'm a capitalist and I want the market to work its way through, there is such a time lag between when you have exploration investment and when you're going to actually get results that if you rely on this, we will end up with more bottlenecks in terms of when you need the metals for that critical delivery of energy or other infrastructure. And so this is what needs to change in terms of even, in 2015 when we finished the data there, still 1/3 of the total exploration investment per year was going into gold, and very little going into a lot of these critical metals. Some of them, and we've looked at this in another recent paper, we call them companion metals. Tom Gradle, industrial ecologist at Yale, he came up with this companion metals wheel where he looked at different metals in terms of which are mined with other metals together. So you clearly get a lot of byproduct metals. But even if you consider that, we would not be able, it's not justifiable that there is not enough investment going into some of these other areas that are going to be critical, particularly things like lithium, which is not a critical, it's not a companion metal. It's definitely critical, but not a companion metal. The other important area that I'm now currently working on quite a bit, and University of Delaware is very well positioned for this because we have a strong School of Marine Science and Policy, and we just held a symposium recently at our marine campus. We're doing a book, in fact, on minerals underwater, which will be published in about a year with University of Chicago Press. And that basically, we were looking at the oceans as a potential resource for some of these critical metals, because after many years of there being uncertainty about whether we could mine from the oceans, finally, the International Seabed Authority is issuing regulations and has started to gain that level of momentum that we can foresee within the next few years actual mining underwater. And anytime you say that, people roll their eyes and say, well, will it ever happen because it didn't happen for 20 years? Well, the technology is there. It's just that there were a number of other factors that came up in terms of terrestrial resources being found, other things. So this is one example where mining underwater is likely to be very appropriate for these critical metals. So the largest reserve by some measures, and it's always a bit, when geologists use the term reserve versus resource, reserve meaning that it's actually economically viable to extract versus resource that it's there. The The British Geological Survey would say that this is, in fact, a reserve. This tropic seamount, which is off the coast of the Canary Islands in the Atlantic, is an enormous potential source of tellurium for the solar panels, one of the largest and very high-grade tellurium that they found just 2 years ago. So this is very recent that they found it. Now, oceanic mining, you've got 3 areas. So you've got the Law of the Sea Convention, which has basically established the International Seabed Authority, and that has delineated essentially 3 areas of minerals that you can extract in different ways. There are the minerals which are in what we call manganese nodules, which are at the base of the deep sea, and those are usually manganese, cobalt, and they're huge, the amount of area that they are covered in, especially in the Central Pacific. They're called the Clarion-Clipperton Zone, which is south of Hawaii. There's a huge area where you have these nodules that have just precipitated out metals. And in fact, geoscientists don't quite know why that has happened, because they're really bizarre potato-like structures which are all over scattered over, twice the size of Texas area, basically. So that's a potential one. The other one is what we call these crusts, metal-rich crusts, which are on top of sea mountains. And then the third one is the one that gets the most publicity, is the hydrothermal vents, where you have these weird, large worms and, chemosynthetic organisms and all, which people are like, wow, this is such special biodiversity, and if you do mining there, you're going to ruin this. But I don't think there should be mining in the hydrothermal vents. But these 2 areas, the manganese nodules and the cobalt-rich crusts, I think they deserve considerable attention and will likely move forward. And then you do have some mining that's happening in the continental shelf, or also there are legal aspects to it, which if you want in the Q&A section I can go over, whether it's in the exclusive economic zone of the country or whether it's in the open seas. And if it's in the exclusive economic zone, then the country can make the decision on their own. If it's in the open seas, you need to get the International Seabed Authority, which is based in Kingston, Jamaica, to issue a license and so on through that. Now, what we're suggesting is, some kind of mechanism around governance. So lithium, some colleagues in Australia, they did suggest this kind of an institutional mechanism for trying to govern the lithium supply. Here you've got basically the role for knowledge provision coming from the scientific community, and then you have the institutional setting. And this is just a simple kind of a layout of what would be covered around this. And they've got this kind of x-axis going mining to recycling disposal, so it's sort of life cycle of the mine approach. And this was published in Science of the Total Environment some years ago. If we refine this kind of a model further, there has been also the call to have a mineral covenant, which, for example, was suggested in this case, particularly around automotive manufacturers between the EU, Nigeria, and Kazakhstan. So it's just to give you a sense of how people have been thinking about finding ways of better governing the mineral supply chain. And then this is something we have just published. This just came out, actually. It's one of those papers which is online, and it's Back to the Future. It's actually publication date is December of this year. But it's a paper that focuses on a model which I worked on with some colleagues at the Columbia Center on Sustainable Investment around how you can have a public-private partnership around exploration. And we think this would be a really good way by which the ERGI, where I started the presentation, the Energy Resource Governance Initiative, could look forward. So here we've got, in orange is the private sector, green is the government, and the black is the public-private partnership, the PPP. So, when I was saying there's a market failure, the problem is that you need to have some public sector injection, and you also need the supply sources to be better communicating with the demand sources. So if you look on the right side of the diagram, the bottom right, you have these green technology firms, many of which might be in Austin, who are developing new technologies for solar panels or wind or whatever, and they have some proprietary needs, about this metal is what we need for this technology, right? But there isn't very good communication from them if they were to upscale that demand. Where will it come from? So what we have suggested is that there needs to be this kind of a mechanism at the international level to be able to communicate better between the demand and the supply centers, and not just look at mining, but to look at recycling. So we have that up there as well. There's also a role for national labs. There's a role for support to assess the criticality. So we've listed, for example, the Green Climate Fund, which should be investing in such projects. This is a huge fund at $100 billion targeted for helping countries to reach their climate change mitigation targets. It's based in South Korea. Right now it's still being replenished to that point. It doesn't have as much funding right now, but it's already reaching several $billion. But that's the target, and this comes out of the Copenhagen Agreement, even before Paris, that established the Green Climate Fund. Then you have the International Finance Corporation of the World Bank, which their mandate is to help private sector investment in high-risk countries, where you might have these metals. And you have MIGA, which is the Multilateral Investment Guarantee Agency, which is like an insurance arm of the World Bank that helps, like if you want to start a mine in Afghanistan, well, it's such a high-risk country that people would not give you insurance. So the World Bank comes in and says, we'll give you the insurance to go in. So you need those people to be more engaged in this area so that then you are able to develop a much better communication and efficient system for governing this. And we call it the Smart Mineral Enterprise Development Model. We use the term smart in the same vein as we use it in smart cities, which is feedback loops. So you're able to get, very good communication from the demand and supply, so hence it's being referred to as such. So some further efforts, and then I'm going to end in a minute or two. There is some hope also that some institutions are emerging to deal with this problem, but they need teeth. Right now, many of them are just, people getting together in fancy hotels and singing Kumbaya, which is not going to help. So you need really to have some real action coming out of it. So one of this is the Intergovernmental Forum on Mining, Metals and Sustainable Development. This was an initiative from the Canadian government, Canada being a major resource power, at least it thinks of itself as such, I think validly so. And so, they invested about $10-15 million in setting up this entity where basically they get countries to become members of this forum. And through that membership, they get certain support services to improve their governance of the extractive industries. And they have now over 60 countries which are members. And they have some unlikely sources, countries which you wouldn't think would be members, like Russia and Iran are members as well. And every year they meet in Geneva. They don't want to meet in Ottawa. They would rather meet in Geneva. It's central, and they have the great, Palais des Nations, where they meet for about a week, and they talk about what they're going to do in terms of improving their the governance of the extractive sector. The World Bank just launched in May the Climate Smart Mining Initiative. And this is an effort from the bank to focus specifically on the renewable energy technology sector so that their investments are much more geared towards helping those countries source these technologies for this. But they have been very modest. Like, for example, they have not looked at oceans. They're very focused on, much smaller projects currently, but it's just launched. So let's see what they do. It's one to keep an eye on. I was one of the speakers at the launch event in May, and it was well attended. They had like 700 people there, and lots of positive energy around it. You had, in fact, the president of the bank also spoke, and so on. You have then the International Seabed Authority that I mentioned, which is based in Kingston. They are doing the review of the regulations, so I'm hoping by the middle of next year, we will have these regulations issued so that then you can have environmentally conscious extraction of the oceans. And this is where, definitely as someone who's sensitive to environmental concerns, it's rare that we have a chance to actually enable environmental regulations before a development. Usually environmental regulations are reactive. after we have a spill, then Congress passes something. This is one of those very rare opportunities where we are being able to plan regulations before a major new kind of development. And that is why organizations like the Pew Charitable Trusts are very invested in involvement in this area. But Pew, interestingly enough, has its origins in oil because the fortune was made by Sun Oil, but they do mostly now work on environmental conservation and the like. Australian government's new CRC, there was a cooperative research center that has been set up on batteries, and I know in UT Austin you have very good batteries work that's going on as well. So this is a new initiative to focus on batteries and recycling of materials from batteries because that's where a lot of this critical metals material is going to end up. So how to find better ways of recycling those. That's one to keep an eye on. They have especially lithium focus there, and it's based in Western Australia at Curtin University in Perth. All right, so those are some efforts. So I'll just end with a famous quotation of from one of these books on the chemical industry going back to 1924, but it's one that I often use. I used it in one of my books many years ago, that those of you, especially who are students, I hope you will always keep that sense of wonder about the elements. Energy and the elements are so inextricably interconnected, but we often miss that connection. So I hope that that will leave you with some modest inspiration, and I'm happy to take your questions. Okay.
Start it off. Oh, okay.
I'm just curious with respect to these international institutions, to what extent you see a buy-in or the prospect of defections such as has happened where the U.S. has pulled out of certain international agreements and so on. Not picking on the U.S., other countries might also decide it's against their interest to participate. How solid do you think this emerging coalition is?
Yes, so currently we do not have hard international law. Most of it is soft international law, meaning that countries can make what they call legally binding commitments, but the legally binding commitment is as long as they want to follow the law. So it's a very important question. I think what ultimately happens is that there needs to be a recognition around public shaming and the willingness of countries to engage in sanctions and so on if there is not a commitment. And I do think we're moving towards a situation where there will be more willingness to do that. So there is one institution which can make a big difference, and that's the UN Security Council. Now the UN has many problems in terms of its structure because it's a vestige of the post-World War II establishment, and so the permanent members are not representative in some ways of the current demography or even power for that matter of the world. So for example, Germany is not a member of the permanent member of the Security Council, even though it's Europe's largest country, but it was the losing power in World War II. Japan, similarly, is not, even though it's the largest contributor by some measures to the UN budget, including to the Global Environmental Facility, the Multilateral Trust Fund for the Environment. Japan is the largest contributor. So there are problems, but the Security Council can pass resolutions with teeth, and they have started looking at minerals, especially since the conflicts in Sierra Leone and Liberia, which were linked to minerals. So the Security Council actually got involved and issued some very clear series of injunctions around sanctions regarding the rebels in Sierra Leone and Liberia. So there is, I think, potential that the Security Council could get more involved and see that as being a priority, that energy security is an area that the Security Council should be involved in. But you're absolutely right that the treaties themselves, they don't have teeth without some other backing that comes from either the Security Council or the World Trade Organization, for example, which also has more clout in those domains. So we have to definitely work on those aspects of leveraging the power.
Hi, thank you for the interesting talk. So my question is about recycling the rare earth metals. So what are the energy costs associated with recycling these metals? Because at the end of the day, it is increasing the total energy of, total energy to produce, energy
Yep.
production.
Yep.
So what are the estimates in terms of percentage, or how much is it going to affect the?
Yep. It varies a lot from metal to, like aluminum or aluminium as you call it across the Atlantic is one case in point where recycling is far less energy intensive, and that's why, we're, wrapping our sandwiches in aluminum now, where at one time it was more expensive than gold, right? There was a time when aluminum was so expensive. It's all dependent on the technologies which are going to be available and the modularity of the products which you are designing. So one of the reasons why aluminum is so cheap to recycle is because it's highly modular in terms of a lot of the products that are made. So it's very easy to take out the aluminum, the cans or whatever, and then recycle them. It's much more difficult with rare earths, for example, because they are embedded inside your iPhone screen. So it's much more difficult to be able to extract them, and the percentage in some cases of the element in that anthropogenic mineral, as my friend at Tsinghua would call it, is much less than even in the ore sometimes. So it depends on the metal. Your question is very important, that ultimately it's going to be about figuring out the energy budgeting, and but that's where the research is most important, and we need that push to be able to get, it's a design problem, and it's also a technological chemical engineering problem in terms of the extraction. The design has to come first. So, like Apple has made this new commitment that they're going to make their phones far more recyclable by design changes. And they have a video on YouTube which is really cool, that this robot is disassembling the iPhone, and metals are going in different places and so on. So that can solve it, but you also need the technical solution so that you need less energy in order to recycle them. But absolutely a fertile area for research.
Hi, my question's more so on the reserves that you talked about in the later part of your presentation. I know for fossil fuels, oftentimes it's talked about reserves and based off of different demand levels, how long those reserves will be around for. In terms of critical earth minerals, that's something I have no knowledge on as far as how many years we have reserves for different minerals. Could you just talk a little bit on, what these different reserves look like for different critical metals?
Yes, no, good question. So we have one of those peak charts in our Nature paper if you want to look at, this is a highly controversial area in economic geology, anything with peaks. The people in the Colorado School of Mines, they get panic attacks if you show a peak, but because they feel that ultimately history has defied peaks, where peaks have always moved, and we've always found new technologies, and there is no such thing as a peak until the inner core of the earth is exhausted or something. But anyhow, so it's a controversial topic given that, but I would say that generally speaking, exhaustion of particular metallic reserves is going to be linked to those demand curves that I was showing you, right? So, and then it's all about the concentration levels. Like rare earths, people say, well, they're not really rare because ultimately in small amounts you find them even in the soil outside, right? So it's more a matter of can we find the right technologies to harness them. So it's more the distribution side, and so then can we convert the resource into a reserve. So people are very hesitant to generate those peak curves around metals. We did it for copper, and we based it on what was being projected in terms of decline in ore grade, and we also looked at some of the data from copper mining companies that one of my colleagues at Monash University in Australia had scoured all the copper mining company reports about projections and so on. And we did project that where, in about, it was I think like 2080 or so, you get a peak in terms of, and we also looked at it by country. So we looked like Chile is the largest copper producer right now. So we looked at Chile being, when will it go down and what other potential places will come up. So that's why it's a tricky one. Your question is an important one, but it's one that we were, I think, bold enough to try to address it. So I'd urge you to have a look at our paper and especially look at the supplementary material section, which good students should always do, and you will find some further material on it, yes.
Hi, thank you for your talk. It was really good. I have a question. Are there any mechanisms to ensure that whenever there's mining done in the developing world, the economic benefits are spread throughout the population? Because, for example, in the case of oil and gas, let's say in Africa, a lot of that money has been concentrated in few hands and the population doesn't get the benefits of this.
Yes, no, it's absolutely the case in terms of, this is what we call the resource curse or the paradox of plenty. There's structural reasons why mineral wealth leads to a high accumulation of capital to a very few people. I mean, we have the example in the US in terms of the Rockefellers and the Carnegies and so on, that there was accumulation of wealth in very few. And so then you have to figure out, because it's a high risk, high reward industry. So there are very few people who want to take those risks and then they get a huge amount of reward. So then there's a role for some kind of better dispersion. So Rockefellers were philanthropic, but they did have to break up Standard Oil to really make a difference, right, in terms of how the wealth was going to be distributed. Similarly, in the case of, in African countries, you have some state-owned companies, but you have high levels of corruption, which have resulted in there not being an ability to have that same impact. But we have good examples, and the usual perennial good example is Norway, right? So Norway is a country which established a sovereign wealth fund, which is now over $1 trillion. That means every Norwegian is essentially a millionaire forever if they really wanted to, because it's a country of, a few million people, 5-6 million people. So you do have, and it's oil wealth. I mean, Norway used to be the backwater of Europe, as the Swedes always, they colonized Norway, and they're, now they're far ahead. Sweden was the great industrial power of Scandinavia. Volvo and IKEA and all that is there, but Norway is far ahead in terms of those. So because, why did they do? They set up a sovereign wealth fund. They had a very clear plan for managing the revenues. Unfortunately, Nigeria didn't do that. And the argument sadly was because of economists at the time, some were arguing that, when you're a developing country, you need to inject capital right away into development. So you build infrastructure. So what did Nigeria did? These weird infrastructure projects, like they built Abuja, a new capital in the middle of the country, because they felt we needed development now. I think that was a big mistake. They have now set up a sovereign wealth fund much later. So I think those are some mechanisms to allow for transference. Local procurement policies, ensuring that companies, I did some training in Nigeria for Shell, and I was appalled that the food was being flown in from Paris, for the people who were living there, and it was at the time where, why aren't you locally sourcing the food? They're all living in this compound, which is like seemed like you're in a total bubble, and some of you may have visited that place, but these kinds of things where you were like, why can't you make small differences where you are doing more local? Now they have learned. It's not to say, Shell has tried to make changes, but there are small things which you can do to make sure that the economic benefit has more of a local footprint. Sovereign wealth funds at the macro level, local sourcing, figuring out. The other big mistake that that has been made is that there's been a tendency to focus a lot of the injection of wealth at the central government level without where the oil is being extracted. So there needs to be, and that's what leads to conflict. When you don't have strong nationalism and you have people putting in the money coming out of an area into the central coffers and not local development, it will make a difference. So that's been one of the problems, and that leads to conflict, and that leads to further corruption and issues that then lead to those problems. But we have some success stories, so it's not fatalistic that people are going to have that.
Just from this PowerPoint, like we saw a lot of these rare earth metals are coming from a lot of countries overseas. Are we seeing like a really, really big push to try to do more, what is it, like find those same resources here in the U.S. versus like looking more outside of those other countries?
So more looking at U.S. domestic resources, that's one of the mandates of the executive order, is to look more for, so the one thing is to remember is before China became a rare earth superpower in the 1990s, the largest rare earth mine was in the U.S. It's Mountain Pass in Nevada, California border. It's actually in California, but it's right on the border with Nevada. But that closed for environmental reasons initially, but there were also economic reasons in terms of processing and so on. But when the Critical Materials Institute was set up, that was one of the goals, was that they would try to inject capital to bring Mountain Pass back into production. That may still happen, but there are these other variables which come into play as well, because the rare earth processing is very chemically intensive, and it has certain other aspects to it which is difficult to do in the US currently. So Australia is a similar situation, that the rare earths are mined in Mount Weld and they're processed in Malaysia by Lynas Corporation. So that's the challenge. They're trying, and that's in the mandate. But we have to think about, if we just don't have them, then what do you do? Because that's what I was saying, geologically, there are limitations. Yes, you may find some, but it may just so happen that, just like oil reserves are, just some areas are more blessed with them, similarly with metals too.
Thank you for the interesting topic. My question is the marine mining. I found like two issues. One for the environmental pollution caused in the sea areas, and also the ecosystem disturbance.
Yes.
So how these two issues, say like if the pollution is going up, anti-pollution laws will be going to be more strengthened, and the cost of the water, the production will go high, and also the disturbance with the ecosystem is obvious with any kind of a mining thing.
Yeah.
So how these two issues going to affect the production and also the cost and the associated with the industries with that
It should be internalized as a cost of production. I mean, we can't, you can't have a race to the bottom. Environmental costs have to be considered as part of cost of doing business. And this is the irony of the China case, is that when China, had that supply crunch of rare earths, what they said was they were closing some of their rare earth mines because they were environmentally damaging. And then the US, the European Union, and Japan took China to the World Trade Organization's dispute panel, saying that they were being unfair in terms of supply constraints for a commodity. And the Chinese were saying, we're doing it because you keep blaming us for being dirty industries. And we're trying to clean up by closing some of the mines to clean them up. Now, whether you want to believe them or not, that was what they did, was they cleaned them up afterwards. But the World Trade Organization Dispute Resolution Panel voted against China, saying that, yes, they have to make sure that the supply is accessible, because you cannot constrain it under those conditions. So unfortunately, the environment is not considered by the WTO's rulings thus far. We have found them not to be very sympathetic to environmental concerns on those kinds of policies. And but ultimately, we will need to, because then you will end up paying some other price. And we see that now, you can get economic analysis of how much pollution costs countries. And there is a real cost to pollution in terms of economic growth. China itself estimated that their economic growth during the periods from like the start of the millennium to 2010, about 1.5% of their economic growth was reduced because of pollution. Because people can't, people are not able to go to work. They can't, they're physically falling ill. So it's not just like, it's not a tree hugger thing. It's like there are real palpable impacts. And that's what people are realizing now. So.
All right, we'll go with one more question.
Yeah, I was wondering if you knew anything about the potential of oversaturating the market with some of these metals, and if that were to be the case, is that good, is that bad, or what would that mean?
Yes, I mean, so there is a case for stockpiling. And one of the recommendations we put in the Nature paper was that we should have a stockpile of more. The U.S. used to have critical metal stockpiles. I mean, we have like a reserve on petroleum, which we just had to use with regard to the fires in Saudi Arabia, the attack on Saudi Arabia. So similarly, the U.S. used to have these critical metal stockpiles, and we should have those and to modulate the supply demand in that way. So if there's an oversupply, I think there should be a mechanism to have a stockpiling for some of these critical metals so as to not lead to wastage, because that's the real concern. Is if you don't have, it's not as much just to control the price for profit, it's to prevent wastage. So there should be, I think that's a very important area for further work, is a global stockpile on critical metals that will be needed. So if there is a major find of some kind and a company is afraid that it's going to lead to price decline, then they will be able to put it in a stockpile. But you need a governance mechanism to do these things.
Right. We had the Railroad Commission governing oil flow before the 1970s, and the IEA was formed, which established the oil stockpiles around the world. So maybe the IEA can form a stockpile of critical metals or guide that governance. So thank you, Saleem. Thank you for this great talk, and thank you, audience. Thank you.